Okay, in this video, I just wanted to look at this notation, the z sub alpha, and what that means. Basically, what that means, when it's z sub alpha like that, it means the area to the right of that percent. So z sub 10.10, z sub 10% means the area to the right of that z-score is 10%. So at this point, this z-score has an area to the right of 0.10, probability of 10%. And now we want to know what is that z-score that has the area to the right that's 0.10. Well, there's a couple ways of doing that. We can go to the back of the book and look at the normal table. So if I bring that up, and now this table shows the area to the left of the z-score, but I want to the right. So if it's 0.10 to the right, it must be 0.90 to the left. So I go and I find as close as I can, which is between here and here. And this one's 0.9015, and this one's 0.8997. So this is closer. So it must be right near here, but not quite, right? So I would say 1.28 and maybe 1. 1.281. It's less than half, so we'd round to the 1.28, right? So 1.281 is what I would say. So approximately 1.281. All right, we can go and do this in StatCrunch though as well. Any type of calculation like this can be done there. So let's go do that. So in StatCrunch, just go to Stat, Calculator, and Normal. We want the, of course, mean to be 0 because we're not talking about any data. Standard deviation 1, and then we want it to be greater than, and then this is the one we want to compute. So we want it to be 0.10. We want the probability to be 0.10, and we want to know what z-score this is. 1.28155. So 1.281 or 1.282 is correct. We probably just have the hundredths digit, so 1.28 would be enough. So the 1.28 would be the value where the area is to the right, which is 0.10. Okay, now let's look at a level of confidence. So this question says compute the critical value z sub alpha divided by 2 that corresponds to 91% level of confidence. Okay, well, the level of confidence equation is just basically 1 minus alpha times 100%. So our level of confidence is the 91%. So that would be, in decimal form, 0.91. And we put that in there, and we're going to find what the alpha is. There's a couple ways of doing it. One way is to do this equation, and it's 100%, and I put it in decimal, so it would just be times 1. Okay, if it was a 91%, it would be a percent, but it's times 1. Then we just solve for alpha. 0.91 equals 1 minus alpha, since that's 1 times that. I subtract a 1 on both sides. I get negative 0.9, negative 0.09, right? Equals negative alpha. Divide both sides by negative 1. And then I'm left with 0.09 equals alpha. So what this means is that we have a z critical value of 0.09 divided by 2, or z 0.045, right? So we're looking for the critical value of the z value where 4.5% is to the right. And the reason why we have it divided by 2 is because the 91% level of confidence includes both tails. So when we have 91%, we have the normal curve, and we have this tail and this tail. That means the inner inside here is 91%. So that must be that there's 4.5% over here and 4.5% over here. Well, again, this notation here, this z critical value, is the right value. It's over here. It means that I want 4.5% that way. So you can walk through it with this equation, and then I just go into StatCrunch at the back of the book and I find that value. Or what sometimes I do is I think about this, right? 91%, and I kind of just draw that little map there. 91% in the middle, and then you still need 100%, right? Well, you need 9% split up between both of those. So I just split up the 9%, 4.5%, and 4.5%. You can do that with any of them, and you don't have to go through the equation. Just think about what you need on each side, and then you're always looking at the right side for the value that you need. So 4.5% or 0.045, let's look at it both ways again. So 0.045, that's going to be pretty close up here, right? There, or the next one here, 4.5. So it must be 1.69, maybe 1.691. Let's try that. 1.691. Okay, let's see what StatCrunch says. We'll go over back to that. Same thing here, we just need to change this to the 0.045 to the right, 1.695. Oh, looks like it was a little off, so this is a little bit more accurate. So 1.695, 1.70 would probably be the better, so it's a little bit trickier, so it's better to do it sometimes on the calculator. So 1.695 or 1.70 would be the better option. So 1.70 is the more accurate number for this value. And that would be the z value where 4.5% is to the right. Okay? So you can do it either way, but looks like using the StatCrunch is a little bit better, or using Excel would be a little bit better to get the exact number in order to make sure you're right when you put it in for a problem. All right, other than that, that's how you compute the critical z value. If you have any questions, please let me know.